This video is about the properties of parallelograms, and we'll be talking about 4 properties that you need to know and be able to use. First, the definition of a parallelogram. A parallelogram is a quadrilateral whose opposite sides are parallel. Okay, it's easy to remember because it's a parallelogram. Okay, the opposite sides are parallel. Okay, the first theorem: if a quadrilateral is a parallelogram, then the opposite sides are what? Let me pull up a Geometry Sketchpad file. So I've constructed here a parallelogram. Okay, let me show you the measurements of the the sides. Okay, you may notice that the opposite sides are always congruent. Okay, and that'll always happen for a parallelogram. So the first thing to know is that the opposite sides are congruent. Okay, make sure you have that in your notes. The next idea is about the angles. Let's go back and look at the angles. So here are the angles. If I measure the angles, you may notice a couple of things. First, and most obvious, are that these are the same, and let's see here, that's A and C, so the opposite ones are always congruent. Okay, the other thing to notice, let me kind of find a good angle measure to look this up. There we go. The other thing to notice is that A and B will add up to be 90, and C and D will add up to be 90, and D and A. So the consecutive angles, the angles that are next to each other, will add up to 180. So those are the next 2 properties to know about parallelograms. The consecutive angles are supplementary. I'd have this in your notes. And the opposite angles are congruent. Okay? Now let's use those 3 properties before we hit the last one. The measure of angle A, let's see here. This is 127, and I know that the consecutive angles, the angles that are next to each other, are supplementary. So angle A must be 180 minus 127, and I get 53 degrees. Okay? 53 degrees. The measure of angle D would be the same as B because they're opposite angles. So D must be 127. Okay, the value of X. Now to find the value of X, I need to look at the fact that the opposite sides in a parallelogram are congruent. So X plus 2 would have to be equal to 2X minus 3. And I'll solve this equation by subtracting X from both sides. And then add 3 to both sides. And I get X is equal to 5. Okay, and then I can find AB by plugging that in. 5 plus 2 is 7. Okay, that's using those 3 properties. The last property is about the diagonals. Okay, and this one is probably a little less intuitive than the ones before. Okay, we kind of draw on those diagonals and some of the lengths. Okay, now I've measured here BE and ED. Okay, I've also measured EA and CE. And you may notice that these are always the same, and these are always the same. Okay, or in other words, the diagonals cut each other in half, or they bisect each other. Okay, and that's the last property that you need to know, that in a parallelogram, the diagonals will bisect each other. They'll cut each other in half. So here is a problem that uses that idea. PT is congruent to TR. So these are congruent. And QT is congruent to TS. Okay, so 2x is equal to y plus 3. Okay, now we have x and y in both equations. Okay, so we have a system of equations which you've learned about last year. And one way to solve this is by using substitution. So this is equal to y, so I will take x plus 2 and plug it in here for y, 2x is equal to x plus 2 plus 3, or 2x is equal to x plus 5, and I'll subtract x from both sides, and again I get x is equal to 5. And I'm asked to find the values of x and y. Okay, and once I know x, I can then plug it back in to here, and I get 5 plus 2 is equal to y, so y must be equal to 7. Okay, here is another theorem that you need to be aware of. It's related to parallelograms. If 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So in other words, this is a transversal. Okay, if these lines A, B, C, D, and E, F cut off so that this segment's congruent to this segment, then every other segment that intersects those lines would also be congruent. So this must be congruent to this. Okay, and that's what this theorem is saying. So for example, if CB is congruent to BA, that means that this must be congruent to this. So ED must also be 12, just like EF. So this video was about the properties of parallelograms, and the 4 properties are: the opposite sides are congruent, the consecutive angles are supplementary, the opposite angles are congruent, and that the diagonals bisect each other. And theorem 6-7, which talks about segment lengths when 3 or more parallel lines cut off congruent segments.